Alright, the elimination method is a third way of solving a systems of equations. So hopefully you watched the other videos. One of them is called systems of equations, and there's the equal values and the substitution method in the last couple videos. This method, actually people usually end up preferring this one. It's for figuring out how to solve for x and y when you have two equations. And both equations are usually kind of messed up. They're all mixed up. So like, let's say I gave you 3x minus y equals -2. If I graph this, this is some sort of a line on a graph. And let's say I gave you another line, -2x plus y equals 5. I want to know where do these lines on a graph cross. I want to know what's x equal and what's y going to equal. It's not a good situation to do like the substitution method like in the last video, because no variable is just all by itself. If you look, actually, the way I'm going to solve this is going to be simpler. Remember back in grade school when you learned how to add things up? You put a line underneath and a plus sign. You can actually do that with algebraic equations as well. It's a little more complicated than like in third grade when you're adding up lots of numbers, but it's still the same story. Look what's going to happen if I add these up. Do you see how the x's and the y's and the numbers all kind of line up nicely? If I took a negative y and a positive y, you see how these are matching? And I put them together, I added them together. Well, a negative and a positive always cancel out. So those are going to go away. And actually, this is going to turn into this nice, easy problem. I'm going to have 3x and a minus 2x. 3 minus 2 is 1x. And over here, I'm going to have -2 plus 5. Well, okay, -2 plus 5 is 3. So I have a 1x equals 3. And I could either divide by 1 on both sides, or you don't really need a 1 there. It's just an x. So I get an answer. X equals 3. Done. Solve for x. See how fast that is? Now the only thing we got to do is go over here and write solve for y. And solving for y can be a little more challenging with these elimination problems. It's really not too bad. It's like the other, substitution and equal values method. You always go back and you pick one of the equations to start with. It doesn't matter which one you pick either, whichever one you like. So like let's say you really like the second equation. It was -2x plus y equals 5. Well, we've already solved for x. We got 3 as our answer. So basically you can circle the x and say I'm going to turn that into 3, my answer. So I have -2 times 3 plus y equals 5. And if I put a little line down the middle, this is going to be solvable. -2 times 3 is -6 plus y equals 5. So flip the 6 over, make it a positive 6. Add them together, 5 plus 6, that's 11. We're going to get y equals 11. And now we got our two answers, 3 and 11. And if someone asks you, like, where did these equations, cross on a graph? Where's the point of intersection? You would say 3, 11. And that's your answer. Elimination can get a little bit trickier. It depends on the equations. Sometimes they'll line up really nicely, but nothing actually cancels, nothing eliminates, hence the name eliminate. So you have to do a little bit more work for those ones. Let me kind of show you an example. It's good to see some of the weird ones. So a good example that we can kind of work off of would be something maybe more like this. Let's say you had y minus 3x equals -4. And then the second equation, let's say you had something like 2y minus 4x equals 10. Well, I can kind of tell when I look at this that everything lines up nicely. It's an elimination problem, and I want to add these together. I got y's and x's and 4 and 10 here, but nothing actually eliminates. -3 and -4, those don't cancel. Y and 2y, those don't cancel. So we kind of have a situation. We have a problem. Here's what we can do to fix it. One thing I could see is it would be great. I'm going to use a red pen here, a different color. It would be really great if there was a -2 with this y right here. Now, I can't just make one up and put it there, but look how nice it would be. You'd have a -2y and a 2y, and they would cancel out. It would be beautiful. But if you really want to do that, you need to put a -2 here and here with all three parts of this equation. You can't just put a -2 here and not with the rest of them. So I'm going to multiply -2 by each of these, and what I'm going to do is I'm going to draw a little arrow here, and I'm going to rewrite this equation with the -2's. I'm going to have -2 times y, and then -2 times -3 is positive, so plus 6x, and then -2 times -4 is a positive 8. So I've basically rewritten this equation. The second equation, I didn't do anything to it, and I don't need to. So I'm going to just recopy it. 2y minus 4x equals 10. It's the exact same thing. Now this thing, if I line it up, is perfect because look at the -2y and the positive 2y. Those are going to eliminate. They're gone. So if I get rid of those, the rest of these will be fast. I have 6x minus 4x. That's 2x. I have 8 plus 10. That's 18. I have the answer is 2x equals 18. So divide by 2 on both sides, and x is going to equal 9. It's pretty fast. And then I'm not done with the actual question. I've solved for x. I still got to go back and solve for y. So I'm going to write solve for y. And remember, when you solve for y, you get to go back and pick an equation. You can pick the first equation before we put the -2's with it, or you can pick the second equation, or you can pick the first equation after we multiplied it by -2. It doesn't matter. All three of them are going to give you the right answer. I usually kind of pick the second one, the one that we didn't mess with at all, that 2y minus 4x equals 10, because it's unchanged. We didn't mess with it. It's kind of an easy one to pick. We got the answer is x equals 9. So right here, I'm going to put 9 in there. So I'm going to have 2y minus 4 times 9 equals 10. And then that's the thing we're going to solve. So let's multiply this out. 4 times 9 is 36. So I'm going to have 2y minus 36 equals 10. And then if I flip the 36 over, it'll become a positive 36. And 10 and 36 added together is 46. So I get 2y equals 46. So if I divide by 2 on both sides, y is going to equal, oh, sorry, I'm going off the screen here. So I added 36 over, got 46, and divided by 2. And y is going to equal 46 divided by 2, so we're going to have 23. Which means I now got my two answers, 9 and 23. And if we're trying to be good, if this is a point where it's crossing on the graph, it's at 9, 23. Parentheses around it. And now I've solved for x and solved for y. And that's the basic idea behind the elimination method.